That was hard, sorry. I'm excited about the panel. Hi, welcome back. So we're going to continue now after this short break into the panel on space exploration, the future of space exploration. After all, if there is anything that cannot be denied, is the huge boom of space technology in these recent decades. So while itself, it's thanks to the space race between the former Soviet Union and the United States of America. Although the first ones took the lead with the first man-made object, obviously, with Sputnik, also the first living being with Laika, and finally with the first human on a space flight, Yuri Gagarin, in Vostok 1.
Vostok 1.
Alexandra,
Yes.
sorry, just a point. Do you have any problem with your microphone?
Oh, can you hear me?
Are you muted?
No, I'm unmuted.
It's difficult to listen to you.
I think it's fine.
Yeah,
It's fine.
It breaks up a bit.
Okay, sorry, there
Okay.
was a problem with the sound. Obviously, our guest speakers are already listening to us, so that's completely normal. But we'll introduce you when we finish the introduction to the panel. So Paul?
Let's continue on the presentation of the background of the topic. So, however, after the Russian made some in the space race back in the last century, the American did not stay behind and sent the first man to the moon in Neil Armstrong in 1969, and they are planning to do it again with the Artemis program and getting the first woman and the first color person on the moon. And
Obviously, you can see where we took the inspiration for the title of our conference, which is The Space of Tomorrow, from Vostok to Artemis. So we're just kind of following the path of the space exploration.
So let's introduce our three panelists. So our first guest is joining us from Houston, in Texas. She's the president and founder of Lambent Engineering, and she's the former vice president and general manager of civil space business at Lockheed Martin Space Systems. So welcome, Wanda Sigur.
Hi, it's great to have you with us. So from the United States, we're going also to France. Our second guest speaker is Marc Toussaint. He has over 38 years of experience in the space business, from which 32 were actually in the European Space Agency, in ESA, where he has been working on human spaceflight, space strategy, and also in the Ariane 5 and 6 launchers. Welcome, Marc, with us. It's great to have you also with us.
And our last guest is now joining us from Italy. So Bianca Cefalo is the director of international business and business development at Carbis Corporation, founder at Cosmica Space Consulted Limited, co-founder and CEO at Space Limited. And yeah, Bianca has spent a decade between Germany and the United Kingdom, delivering multidisciplinary and interplanetary mission and also commercial satellites, sponsored by ESA, DLR, UK Space Agency, and also other, including the NASA JPL Insights Mars mission. So welcome, Bianca.
So
Hi, everyone.
Hi, it's great to have you. So as always, we will start with a round of questions. So each of our guests will get a question from left to right, and then we will launch a question, and you're all free to join in, jump in, or complete each other's answers, if that's okay. I would like to start with the first question then for Wanda Sigur. Good afternoon. Well, in your case, good morning, since I think it's 11 a.m. over there. So the question is, actually, we know that the United States is planning to send humans to the moon again, but they are launching more and more rocket technology. But then there's also Russia and China planning to actually collaborate on a station in the moon. And do you think we are facing a new space race to the moon? Over to you whenever you're ready.
Sure. So the question is whether we're in the midst of a new space race, and I would say absolutely, but it never ended. We've always found that there's an opportunity to show where we are smarter, where we are more capable, and where we have the resources to answer those really hard questions like, are we alone? Is there anyone else out there? Where did we come from? All of those really hard questions focus on getting the smartest folks wherever they live in whatever countries and demonstrating that we have solutions. So as more and more folks have a capability to go to space, as we're building more rockets, more systems, as the world shrinks because we're sharing technology, there will always be a race to do the best that we can. So it's not just a race to the moon, but a race to Mars and a race to demonstrate capabilities that engage everyone.
Great, great. That's very interesting
yeah.
and engaging for the future. So the next question will be for Marc Toussaint. So I would ask about, with your experience working at ESA, and so the European Space Agency, the place of Europe in human space exploration has been done through cooperation, like providing some services. Like as Charlotte Besco this morning said, the European service module of the Orion spacecraft for the Artemis program, but ESA doesn't have its own spacecraft and launcher for human flights.
Yeah.
So yeah, what's Europe in this sector is doing and about the future? Oh, you
Yes.
muted, Matt.
Sorry, Marc, can you unmute yourself? I think we cannot hear you. Probably you need to click on the button to unmute yourself.
Yeah, sorry for that.
We're
on the
still
top,
not.
it should be somewhere on the top.
There's
of your
like
screen.
a microphone icon with a line, and probably you have to click it again.
Can you hear me?
That's perfect.
That's perfect.
Thank you so much. Can you please restart your answer? We were not able to hear you.
So the first thing to say is perhaps that if you talk about ESA, ESA is not Europe. ESA is composed of countries from Europe. And for example, there are no real country alone deciding about future of program at ESA. ESA is composed of 26 countries. But among those countries, 4 of them, Germany, France, Italy, and United Kingdom, already contribute for more than 70% of the budget. So there are 4 big countries who push for program, and you can very quickly understand that to move on program, you have to take the train of the big 4 to join large program. With respect to human space flight, is perhaps one of the most sad experience I have from ESA, that we were trying at the time to bring the first human activity called Hermes. It was pushed by France, but after some years of analysis, it was cancelled due to budget and technical issues. We nevertheless, out of the budget allocated, made a demonstration of an atmospheric re-entry demonstrator. It was a capsule, but without any future. It was just to demonstrate that we could use technology we were planning for Hermes at the time, which could be used for demonstrator. Later on, we made another hypersonic re-entry flight with the IXV without going in orbit. And now we are working on another project to go in orbit, which is a bit similar to the X-34B program from the American. So it's quite hard for Europe to take a real place in terms of human space program, large program. We are always cooperating with the others. So when we say cooperating means ESA find a consensus among the different member states, and then we get allowance to contribute on the program. Then we sign MOU with NASA to contribute, for example, to the ISS. And then we get the allowance and the financial support to develop elements or activities to contribute to it. But even there, it's not so obvious why. It's because ESA is not allowed to make any money transfer to the partners. So the way we worked on this cooperation program is to place internal industrial contract in Europe to develop elements and then to give them. It's what we call a barter agreement in order to participate to the program. We don't have a means to go with European in space by our own, so we have to buy tickets. We bought ticket on the shuttle, we bought ticket on the Soyuz, and also many countries in Europe made their own activities, like Germany, France, with the Soviet Union at the time and after the Russian, to go on board Salyut or Mir. Now, for the future, with the gateway proposal from NASA, I think the rule will be nearly the same. It means we contribute to the Artemis program. For example, we are developing the propulsion unit of Orion, just to get, in return of delivering the hardware, the capability to fly astronauts within the Artemis program. So you see, for Europe, it's not so obvious because it's never one country deciding. It's a group of countries, and ESA's role is just try to get a consensus among all those different political strategies or financial support to get everyone agreeing on one common program and contribution. So next step is Artemis, and I hope it will go on. But we will certainly come back because I think when you ask the first question referring to the moon race, we are in a complete different situation as it was before. And ESA sitting in the middle of all different partners, we may contribute certainly to Artemis, but for example, some countries may be interested to contribute with China or Russia on some other activities.
Yes.
So you see already, it's not a straightforward answer to your question. It's really debatable.
I think even though it's maybe not a straightforward answer, you completely, like, you were able to fully take all of the aspects already and answer it in complete. Because actually, I think I completely understand the fact that this need of consensus may slow down these decisions and may also put Europe sometimes not as a main character, but still it doesn't mean that we're not taking part in all of these amazing programs. And actually I'm going to go back and take Wanda Sigur before mentioned the fact that we have never stopped doing the space race. So I want to actually ask Bianca Cefalo, since you have been working from the industry, more private point of view of the space exploration, and you have worked in a lot of projects that actually involve different agencies, as Paul was reading all of them, DLR, NASA, ESA, all of this. Do you think that even though there's no change in the race because it's still the same one, do you think that there's, instead of individual characters now fighting, well, not fighting, but racing each other, do you think that now it's become a team effort instead of an individual work?
Yeah, I think it's exactly from what Marc said. And again, I completely agree on the collective effort. I used to say that now we have actually moved from what it was just a governmental and institutional way of doing business, which started with us, and then of course it started with, in the 69, what we've seen with the moon landing. There was a lot of Cold War, let's say, there was a lot of political reasons around that space race too. What we are seeing now is that, if I think back in when I started working on the Insight Mars mission, it was 10 years ago, that was the only Mars mission that was happening within that time span. And it was done by NASA in collaboration, of course, with the DLR, which is the German Space Agency, with the European Space Agency. So again, there was already a collective effort, because as much as you can do something, you can, let's say, you can have a bid on a massive project. And this is also true for every industry, especially for space. Not all of the subsystems or all the skill set can be done in the same place. So, for example, the InSight Mars mission 10 years ago was a collective effort coming from NASA, of course, and JPL. But the two main instruments that landed on the Martian soil were a seismographer done by CNES, the French space agency, and then there was the HP Cube that was done by the German space agency. And all of that was a massive global effort to put those instruments on Mars. Now, moving 10 years down the line, which means last year, the Martian missions wasn't just one. It wasn't just the Perseverance done by NASA, but it was the Chinese mission, and there was the Emirates mission, HOPE, the HOPE probe. We've seen in 1 year 3 Martian missions from 3 completely different backgrounds coming together. And today there was this amazing picture taken actually by the Chinese lander from a wireless camera, which looked like a futuristic cartoon, but it's actually real. So just in a 10-year span, I have seen that the way humanity as a whole has contributed and wanted to be part of the space industry has completely changed. And if just 10 years back or 20 years back, it was part of some governmental major powers like the States, which is still a major power if we think about it with respect to the UK SA or the European Space Agency. 10 years down the line, there are multiple players. And even when I was working on multiple proposals for the European Space Agency, just in a span of 5 years, I started working on some projects where the big primes, the big industries, usually were the ones winning most of the projects. Then because there was a democratization and a geopolitical return of everybody being involved in the projects, down the line, you could win a project if you had specific companies participating from those countries that usually wouldn't win the projects, like Portugal, like Spain. So even in Europe, as Marc said, there are 4 main powers. The UK and Italy have been part also of the Artemis Accord, and we are fully steam ahead on the Artemis and the moon missions. But now there has been a massive democratization of industries, talents, and privatization of the entire industry, which is allowing, first of all, a collective effort, and also is allowing us to put in place regulations, international regulations, where we can actually allow a safe use of space and a sustainable use of space technologies in a way that is a consortium of people agreeing on that one, not just a couple of powers monopolizing the space.
Exactly. I think you mentioned excellent points, and yeah, about everything which any project now in space is about collaboration. Like, you cannot work alone in space. Even if there are a lot of space to work there, there is no space for single mission. So everyone has to collaborate. And I want to jump on one point on the space mission aspects. So I will ask the question like for everyone, and feel free to jump in to get your point of view. It's a quite simple question that anyone can ask, especially people that are not involved in space projects, because space programs, space exploration programs are quite expensive, and how it does help on Earth, and how can you justify the budget we invest in space exploration mission. So as maybe Wanda, you can start to jump in, as you have a large experience on the space shuttle mission program, and yeah, I think you should have something to tell us.
Sure. There's someone who once said that every dollar that's spent on space is never spent in space, it's spent on the Earth, right? So we are building a capability that I think is informed by really hard questions. One of the examples that's been frequently used is that the cameras that we're all using to talk to each other were developed for space for use for human exploration on orbit. So that capability, that technology was driven by answering a really, really hard question. And to just kind of speak a little bit of what challenges space has driven us to be able to address, I'd like to jump forward the 10 years to talk about European engagement in Perseverance. So at least 3 of the critical instruments and payloads were contributed by smaller countries. You've got the Norwegians who contributed a payload that looked at ground penetrating radar. You've got a couple of contributions from Spain, for example, that were focused on dynamics analysis. And last but not least, a super camera that is giving a level of granularity to the Martian surface that is amazing. All of those things have direct and complete applications on Earth. I see that those really, really hard questions that we have that are including limitations of mass, that are including performance requirements that are very difficult, will drive a technology boom in the I was going to say in the U.S., but it's really around the world, as folks are trying to figure out ways to use that information, that data, and find ways to make money on it. And that, to me, is the seed for where we're going to head with human exploration in the future. We're going to find ways to take advantage of some of those challenges. So, for example, someone mentioned to me that if you were able to generate adequate power capability, and if you have complete and rapid communications capabilities, you can own any planet or moon. So just take that challenge, for example, and imagine if we were going to try to find ways to colonize the moon and colonize Mars. Yeah. Having an ability to, and of course it can't hurt to have the ability to breathe and have water, but having those capabilities such that you could carry it to space means that we would also have those capabilities on Earth, and we perhaps would be able to address some of the areas around the world that have limitations with respect to power access, and have limitations with access to clean water, and so forth.
That's excellent, excellent. I think maybe Marc Toussaint, you could jump on these points and give your point of view on this application from space to Earth. Yeah.
Yes, it's you can look at the problem in the 2 ways. Every activities we do in space has certainly a return on Earth. One example is I worked a lot on the launcher, and on launcher we're using cryogenic liquids. And in the short or medium-term future, we will have to use for Earth application propellant like liquid hydrogen or liquid methane, which will be already dominated by the usage for space activities, especially for rockets. Do you hear me?
Yes, we hear you perfectly.
It's perfectly well.
I had a break, sorry, I had an interruption. So this is an example. You would be perhaps surprised, but in space, we never use the latest electronic technology for mission, often because what we say is the latest electronic technology is not always fully qualified for the space environment. So often what we do is to develop space projects based on old technology. When I say old, it could be 5 to 6 years old, because then we have an experience on how the component behave, or we can test them in some project and after apply them where it's more critical. And so it's one of the things where often people believe that the latest technology is always used in space. It's not always the case. What is also very important is the other way, is how we can transfer technology from Earth to space activities. And it's one of the domains where we have been looking in the past, for example, how to transfer the robotic capabilities, which was used many years ago in a car production facility inside the Columbus laboratory. And the reason is simple, because the crew has a shift of 8 hours work and also 8 hours sleep during the day. we just push the ideas of having robots inside the lab just to do the work when nobody is inside, to complement the astronauts for the work or the research we have to do. And this is also very important, is how we could in the future merge new advanced technology developed on Earth for future space activities. So you see, in the middle of this, you are still with the same question, is on which program and for what? If you want to go to the moon, I think there will be no robots in the gateways, but there might be robots on the moon controlled remotely by astronauts in the gateway. And this is a domain where today there is a lot of investment, a lot of research, especially if you want to take advantage of the fact that robots in the future will have a mandatory role on the moon. Don't forget that the day on the moon is 14 days sun and 14 days night. We will have to find a way to possibly work during the night, not with astronauts, but because it will be quite difficult, but potentially with this type of technology.
Okay, thank you so much. Now let's go. Let's go see if Bianca wants to add something, or if she would prefer that we continue with the next round of questions. Do you have a brief comment?
I can add just very quickly. So there are multiple examples of space. I don't think anything is disjointed. First of all, we're still going through a very critical and historical pandemic, where the digital divide has been shrinked thanks to the satellites application, telecommunications. Multiple materials that have been used for space programs have then been transferred to biomedical applications, or, for example, the memory foam mattress. This is one of the very oldest, the oldest examples of how space applications, aerospace engineering has then been used on a daily basis in our homes. One other example that kind of blew my mind is that I had recently a surgery operation on my foot, and the material, the ceramics that I've used to reconstruct my foot, basically the dentist said is the same ceramic that has been optimized for the space shuttle. So this is something that is embedded in our body, and I myself, I didn't know that. So there are so many applications coming from space to Earth that we probably can even count. Earth observation has been key, especially for water supply management in Africa or the Southeast Asia or in India, for emergency responders when something happens and the cable are all completely broken due to tornadoes, earthquakes, tsunamis, and the only way for responders to receive information and notification is thanks to all the data that is stored in the satellites. So all I want to say is that the more we are moving towards exponential technologies into space and advancing onto those, the more our life on Earth as we know it and as we will know it in space is joined to that. So the more we are moving towards the interplanetary missions, the more we are making our life on Earth better and clearly different from what we knew.
Okay, I think that was actually, I didn't know about the ceramic that they use for the space shuttle is also actually...
Me neither.
It's quite a surprising application I could have never imagined. So I think from this round of questions, the first round of questions, we can say that the main points was that how important the collaboration between the different countries is. So now I'm going to open a new one. It's going to be focused more on the public and private sides of the space agency. Of the space exploration. So for that, there's obviously, we know why public agencies use or invest so much in this kind of programs, because there's a lot of applications for Earth life. So I want to continue with Wanda Sigur. You have more experience in private companies. You're currently committed to helping emerging companies. What do you think of companies like SpaceX or Virgin Galactic making their way into space? Do you think, obviously, their goals are more likely to be economic, but do you think that space is such a profitable business? Over to you, by the way.
That's a great question. The the question is whether the businesses that are currently learning the ins and outs of how to make money in space are focused solely on making profit, or whether there's something else there. So probably, let me start with one thing, which is a little bit of a follow-on to your last question. Besides the things that we do in space, one of the biggest benefits that we get is that we are training, we are inspiring, and we are driving a level of knowledge and capability in our youth, because they get inspired by the things that we do. There is a wealth of knowledge that comes about just because someone sees something really hard being done. And that level of energy is what inspires young boys and girls to become scientists or engineers. And it also inspires folks that have a whole lot of money in their pockets. The folks that are the CEOs of the SpaceX organizations and Virgin Galactic and Amazon and Blue Origin, they were bitten by that bug. They saw something either as part of the Apollo programs or as part of the space shuttle programs that spoke to them personally to say there's something bigger. There's some way for me to contribute in a larger way. And I think that's what you're seeing today mostly. You're seeing that energy of folks with a lot of money trying to change the world in a way that has them as a key participant in driving folks forward. The only economy that exists right now is one that's sponsored by the government. There are no customers yet for anything in space, but that's just the beginning. There is an investment that's required for us to start generating an economy. There is an investment that's required on the parts of government to get more engineers involved. There's an investment that's required to develop that customer and a supplier relationship, and we're just seeing the beginnings of that. And so it's just exciting to be part of that at the very, very beginning, because you're seeing the big guys, but what you don't see are that there are thousands of small guys. It's the worldwide space economy is a $380 billion industry, and even though you do see the launch vehicles, there are things that are happening in every country that has the ability to invest in technology, whether it's a small launch capability or things that are being done in England. Rutherford Apple Laboratory has knowledge and capability in building these very small payloads that I think will totally revolutionize what we consider the capabilities of small satellites to be able to do. Linking those things together, I think, will create that economy. That it will create a pull for knowledge. And so I, for the most part, would say watch that space, pun intended, because we are at the beginning of the opportunities for space economy. Definitely.
And that's the right transition to the next question I will ask to Marc Toussaint about. So there has always been business in space on communication and so on, but on exploration and life, human life in space, not really. But there already have been some space tourisms with who flew in Soyuz, and now the space tourism is really exploding actually in the next few years with companies such as Axiom or Blue Origin that's quite recently offered a place. So if someone wants to go into space like for a few millions of dollars,
only like 55,
it's kind of
cheap,
you can go. So what do you think about this business opportunity on space tourism?
I am myself convinced that the future of space is certainly space tourism, because it will give opportunity to many people, not necessarily in a short time, but in the medium term, many people will have the capability to go in space. I see an analogy with the development of aviation last century. If you just go back one century back, in the year 2030s, 1930s, for example, it was the beginning of aviation. And it took nearly 40 years until 1969, 70, when a major change occurred when at that time Boeing introduced the 747, which just revolutionized completely the access to nearly anybody to travel around the world. And if you look in 2019, that I think it's 4.5 billion passengers have been taking a plane, regular plane, to travel within 1 year, 4.5 billion passengers.
That's
If
crazy.
you would have said this 1 century ago, you would have been sent in jail immediately. Nobody would have trusted you or say, he is crazy. So I believe that space tourism will come after the start of the suborbital activities, which are now within the hand of Blue Origin and Virgin Galactic. It's just, a first step. It's
Yes.
like when 1 century ago people were just buying their own plane. It was at that time millionaire. Now we have billionaire on Earth. And those people have already been flying in the ISS. Even if you look what's happened after the first flight of the Dragon 2, it was immediately a decision to move to at least 4 Axiom flights being registered, plus an independent flight of Dragon 2 with 4 people on board. And this will take place, when is it? This year, in September or October. So you can see already the interest and the boost which will come after. I know it's hard to predict the future, especially, when you look around of what's happening around you, but you have to be visionary. I believe that within 50 years from now, or maybe a bit more, I don't know, but tourism will go certainly regularly in space around the Earth and also on the moon. Because if you want to develop the moon to extract resources, you will have small cities at the beginning, you will have more factories at the beginning, and later on it will develop. The Chinese were saying that by 2050, there will be a business of, I don't remember the exact figure, but trillions of dollars of exchange between the moon and the Earth. You cannot do this without having people moving back and forth between the Earth and the moon. You will be the workers, but we have also the family after and also the tourists. So there will be a big chance for space tourism to develop. There are already a lot of studies on space hotel, space tourism, and I wouldn't be surprised that by even 2030, there will already be some small or perhaps medium-sized station for space tourism.
Actually,
would be great.
Yeah, actually, there's another big point that I think we can all agree on, which is that private companies usually, since they usually have more money or they have to at least give less explanations to everyone, as we just discussed in the previous round of questions with the European Space Agency having to agree with all of its members and these kind of things. I want to ask the next question to Bianca Tefalo. So actually, private companies usually, since they have this money, they're more able to better sell their projects. They are able to better do some publicity for these projects. What do you think agencies, public agencies in particular, are doing to promote their work? Are they reaching out to the public enough? And in specific, are they reaching out to the younger generation? Because of course we have SpaceX with the Tesla, and obviously we all know about it. But what are space agencies doing about it?
So let's say that we are, as Wanda said, we are really at the booming of the new space economy. And by new space economy, we are really including all of the private, small, medium startup, or even bigger companies like SpaceX, which are, let's say, moving away from the bureaucracy or the heavy procedures that are clearly part of a military environment, a governmental environment, institutions, or larger corporations. What the let's say the private has shifted the popular opinion. let's say that within these years, so what is happening from an economic and political aspects in the industry is having a major effect on an ethical, even religious and cultural, social way of looking at space. I remember when I started studying aerospace engineering, which was more than 10 years ago, there wasn't so much buzz about the space industry, about the agencies. The agencies were keeping themselves quiet. They weren't really doing much outreach. I didn't see when I was now you see 20s or even teenagers, small kids. They have an exposure to the space industry, what's happening in space, what astronomy, what NASA is doing, what the European Space Agency is doing. The exposure that I have to those people, even us, for example, today, we are exposed to students all over the world and other leaders in the industry, which didn't happen, for example, even when I was studying. So that's, first of all, the major shift. And the agencies and the institutions, then all the bodies that were more conservative are riding that wave because, again, it is a collective effort. It is through the private sectors, industries, startups, SMEs. Some of them, they are already coming from founders who had already founded something and they made billions, like, we know the names in the industry. Some others are coming, for example, like me. I wasn't one of the billionaires and I just started a new space company based in the UK. What the private is driving is the innovation, let's say. Or as you said, guys, let's say when you are private and you have a small team, you don't have to go through all those checks, all those, let's say, intersections of signing papers. You are a small team, you are very driven, you have that visionary idea and you just make it happen. But that doesn't happen without checking out with regulations. That doesn't happen without approvals from all the federations for your space objects to go into space. Now more than ever, if you consider the space debris problem and again, the sustainability of advanced technology in space. Now we are seeing an emerging market, which is the in-space services, the in-space operations and infrastructures, where, again, people are going to be for much longer time in space, and they will be using 3D printing facilities to build that rocket, that hub, that whatever we're going to see on another planet, or even through planets, directly in space. So this is the future, which requires outreach, because people, the entire humanity needs to be exposed to what is going to happen. And this has to come from all the different players, from the government, from the institutions, from the private, from the schools, from the university. The exposures that now is needed is that not only also engineers or astronauts are needed in the industry, but a plethora of skills from lawyers to doctors, to artists, to visual creators, to copywriters. Everybody will have a space in space, literally, and everybody is needed to build that next step of evolution in space. We are already seeing that, and in a couple of, maybe in a century, again, what we are seeing now is completely out of mind from people a century ago. What we will see in a century from now is going to be even more out of mind than probably what we are talking about today. But everybody is required to expose ideas and to make them accessible to the public, because the public is the first audience that needs to understand where the evolution of humanity is going, why we are doing this, and what's good for them. Should we be scared about the evolution in space? What's going to happen with AI and all, the blockchain happening? Everything is virtual. We have no control about the technology that is going so fast. Everybody has a role, and everybody has to play an outreach role from an ethical and political point of view.
Actually, I love the quote you just said, the sentence you just said about everybody needs to know where the future of humanity is going. I think it's a very good sentence. So, very good point.
Yeah, that's good. Okay, so perfect. Let's now keep our three panelists together so that you can we can have a discussion with all of you. And so let's go, like our conference today is Space of Tomorrow, so from Vostok to Artemis. So I would suggest to go a bit more in detail on Artemis and like what is the main purpose. And I mean, like Artemis is going to go back on the moon. And yeah, so how is it? Do you see Artemis program as much as an achievement as huge as Apollo program, or do you feel like it's quite equivalent and like people can just think we already went to the moon, why do we go there back again, and why don't we just go further right now? So if any of you could start by getting his point of view on that. Feel free.
The first one that speaks has the word, so just whenever you're ready.
I'll jump in. One of the things that I think was surprising to me personally was a perspective that I got in reaching out to young students and sharing what I did for a living. I had a chance to make a presentation of some of the accomplishments and where we were with the shuttle program, and talk a little bit about our robotic development activities, which I thought were amazing, in that we had missions planned to the moon, to an asteroid, to Mars. And I noticed that the kids were looking at their phones. They weren't paying attention necessarily. And when I tried to get them more engaged, they said that the space program was their grandfather's program. They saw going to the moon as being something that was accomplished a long time ago, and they wanted to hear something new, and they really weren't into what was going on in space. Fast forward to a vision for putting boots on Mars, and everybody leaned in. There was an expectation just 3 years behind that first meeting where kids saw themselves as part of a program of going to Mars. They saw themselves because of some of the things that had been accomplished by the private companies, by SpaceX and Blue Origin, and they saw themselves with a role. There was a company that had an initiative on Indiegogo where they were selling one-way tickets to Mars, and folks were just excited about being part of a new vision for space. And that idea of getting from a program that was amazing and accomplished so much 50 years ago to one where folks could see themselves as part of a mission to Mars, to me is the difference between the Apollo program and the Artemis program. What Artemis is, at least from my perspective, is that thought out vision to say, we're actually going to go to Mars and we're going to come back and we're going to take advantage of all the milestones that we've had over the last 50 years. And those milestones include living and learning in low Earth orbit, taking advantage of the International Space Station, taking advantage of the fact that we can test and evaluate new technologies and come back if there is a problem or an issue within hours. We're going to take advantage of the fact that the moon is only a few days away, and we're going to learn about what it takes to generate oxygen, to live, to have environments, and take that information. If there's a problem or an issue, we can be back in a few days. And oh, by the way, we're going to build a little mini space station around the moon in order to accommodate any issues or challenges, or even exercise robots on the surface, which might be beneficial at Mars. And then before we take that many-month journey, we're going to figure out what it takes for us to really make this happen. And it's going to take everybody. And to use Bianca's terms, everybody's going to play, because it's going to take more energy, it's going to take more ideas, it's going to take more people. Months to space will require that we're not just talking about technologists, we're talking about psychologists, we're talking about all kinds of things that are necessary to accommodate that many-year activity. And that's the framework for Artemis, to say we're going to do it thoughtfully, we're going to figure out ways for us to do it safely, we're going to figure out ways to transition America, and everybody will play. And so it's not just the hardware, it's not just the vision, it's not just the capsules, it's not just the pieces, but it includes looking at international law. So the Artemis Accords went out there and looked at folks to say, well, let's look at what we have in outer space treaties. Let's look at what we have associated with space debris and figure out ways for all of us to get our head around this longer vision.
Wow. Thank you so much for going over. I think it was a great overview of the question itself. Can we maybe go now to Bianca and then we'll finish with Marc? What's your personal view on this and what do you think it's there for the next step in space exploration? Is it going farther? Is it staying longer outside? What do you think is the next step?
Yeah, first of all, I love that Wanda just mentioned the fact that the moon mission was for our grandfathers, because this is exactly the same reaction I got last year when I used to go for rocket science workshop in a girls' school in London. And anytime I would go there, they weren't expecting somebody like me. They weren't expecting the usual stereotype of an engineer. And they used to tell me I was never interested in knowing what was this all about and where we are going and what we are doing, because I always thought that's something that my grandfather would do, not a girl that looks like me. So that's what the Artemis and the entire space industry, social and cultural shift has happened over the past year. Is really to express the idea that there isn't any more a gender difference. So that's the very first important step that the Artemis is doing. And we are seeing more and more female astronauts going into space as commercial astronauts, as mothers, as people that at the very beginning of the space flights missions, we wouldn't think they would go into space. Now this is happening, and the Artemis, which the name by itself is the twin sister of Apollo, is purposefully used because of that, to represent genders that have always been a minority, and justifiably a minority in the space industry. So that's the very first thing. Then moving on to summarizing if the space exploration is going to move farther and how. Yes, and at the moment we are just talking about the gateway Earth, Moon, Mars, because these are the closest that we have to ourselves. But let's talk about the next mission to Venus. Both NASA and the European Space Agency have recently announced the next science missions to Venus. Last year, we had the information about the phosphine that was captured in the clouds of Venus, and that could possibly lead to existence of organisms that are living entities. So there is, besides our life in the circle of Moon, Earth, and Mars, there is what is space exploration beyond our usual knowledge, our usual interplanetary moves. And this is deep space exploration. This is going to Jupiter, of course. This is going to the moons of Jupiter. This is going to Venus. This is going to Neptune, to the interstellar medium. And I know multiple, again, private companies that are working on that kind of missions using quantum-based technologies, trying to understand what kind of exoplanets are out there and what kind of places could possibly resemble our Earth. So there is obviously a focus across Moon and Mars because they are the closest and the easiest to be reached at the moment. But there is a whole lot of solar system exploration which is going beyond what we know today. And I think that's even more interesting than even going to Mars, because that's really gonna tell us more about our history, probably we're gonna know way more about our evolution as a species going beyond Mars than just reaching Mars and coming back.
Okay, actually, before giving the word to Marc, I would like to add, actually, you made I really liked your first point on how we're retaking this role of the woman in engineering, and also I think the Artemis program is also looking forward to not only those kind of minorities, but also concerning people of color and trying to also make justice to these other minorities, and I think it's just as important as for the case of women. So
And to jump into Marc, I think you have a bit another point of view on how to see Mars as a target. So I think you let's go. The floor is yours.
Okay, so let perhaps go back to your initial first question. I think it's important to realize the moon race in 1960s, there were only 2 countries in competition, which means each country could decide on its own what to do, what to invest, and how to go. Later on, when we moved on the ISS, the MOU was signed between 1986 and 1987. It took us nearly 22 years to understand how to implement the MOU, to start to build a unit, and only start the implementation of the ISS. Now, there was one leader. United States was leader with Canada, Japan, Europe, and later on Russia joined. And we were all dependent on one transportation system to build the station. So it took us also nearly 22 years to really, or let's say, sorry, I go too fast. It took us nearly 12 years to get to a status where the station would be operational. And we are only experiencing the station for the last 10 years, making experiment on board. And now Artemis is coming, and the proposal initially was to have the same partners from the ISS to join Artemis. When I say this, is to explain that working with different partners is not so easy. It takes time. It's quite a long process to find agreement to decide the start of the project. Now, the world is changing. Russia is leaving the group of partners of the ISS with respect to the Artemis program. Russia and China are deciding to work together. And so we come back in a situation with 2 groups of countries nearly in competition. On one side will be United States, Canada, Europe, and Japan for the Artemis program. On the other side, China and Russia. So what is the future if you start from this basis? Will this be a tremendous boost in terms of competition between the 2, meaning that really people will move fast to the moon and try to extract resources from the moon? I have some doubts that the national agencies, even like NASA or ESA or JAXA, would push for profit on the moon. On another way, China says they want to make profit on the moon. So for them, the moon exploration is linked to profit. Profit is part of what we call private sector, especially in the United States, to invest quickly on new program. Why they can be quick? Because they can decide on their own. They don't have to answer to different partners to make a decision. They are very quick in their decision, and then they can move quickly. Now, why to go to Mars? I think the main reason to go to Mars is science. People would like, as mentioned, to discover the original life. Is there water on Mars? The question on resource on Mars is it's a bit difficult to establish. So to go to Mars is already so complex. I have some doubts that people will move so quickly from the moon to Mars, because each country alone will have difficulties to finance it, to develop all the technology needed for it. We still missed a lot of technology to do the trip to Mars. And the cost is so high. And the question is, do we invest for science or do we invest for return on your investment? And if you look at what the private sector is looking for, and this is valid in Japan, in Europe for some countries, and certainly in the United States, I think people might be more interested, perhaps on some moon resources, perhaps also the resources of the asteroids. because asteroids have been also recognized as a huge area where people could just find new resources necessary for life on Earth or for some other activities. So for me, going to Mars with a huge cost associated to it, and for a result which is science. Science is important, but I believe you can do it with automated system. I think what might be, I say might be because, you know, the future is difficult to predict precisely. What might happen is people will move towards asteroid exploitation, and by the way, they will find that Mars is just between Earth and the asteroid, and at that time Mars could become a base for people exploiting asteroids and having the chance to go to Mars and then exploit things, and after to return what they found either for Mars activities or for Moon activity or for Earth activities. So,
indeed, it does sound,
you know,
like, sorry, it's just that we're running out of time, so I would like to end the panel, if that's okay, on the note you just raised up, which is that actually there's other options besides the planets, which is usually the most direct answer, and we have the asteroids and these kind of things. So I just want to thank you all.
Yeah, and Chris, could you put our
all
three
guests,
panelists
so I
on
can
the
properly
TV so that we can
say goodbye.
See you goodbye.
I just want to thank you all three. I think that I personally enjoyed a lot the panel. It was very interesting. I'm so sorry that we had to just cut it now, but we're going to a very short break before the final talk. So thank you, Wanda Sigur, thank you, Marc Toussaint, and thank you also, Bianca Cefalo. Thank you for coming today.
And wait for the next, yeah. Thank you again.
Thank you.
Thank you.
Thank you. It was great.
It was
so now,
great.
Bye. Now we're going for a very short break, and then we'll be back with our last talk. Jerry Woodfield from NASA talking about the Apollo 11 and 13 missions. Bye. See you soon.
See you soon.
Thank you.
Bye-bye.